Today we're going to practice solving systems of linear inequalities. So let's get started. In this problem, we're asked to solve the following system, and then we're given two linear inequalities. So when we solve a system of linear inequalities, what we will do is graph these two inequalities and see where they overlap. The overlapping region is the solution to the system. Let's take a look at this first inequality. So we have 5x plus 2y less than negative 4. So the boundary line for this inequality is the equation. So we're going to replace that inequality sign with an equal sign. So this boundary line is currently written in standard form, and you can choose how you want to graph this equation. I'm going to graph it by first rewriting it in slope-intercept form. So subtract 5x from both sides. This gives us 2y equal to negative 5x minus 4. And then dividing everything by 2, we get y equal to negative 5 halves x minus 2. So this equation is now in slope-intercept form. We have y equal to mx plus b. So our y-intercept, b, is equal to negative 2. So that means we're going to have the ordered pair 0, negative 2 on our graph. That is our y-intercept. So we can plot that point. And our slope is equal to negative 5 halves. So we can rewrite this as negative 5 over 2. That means we're going to go down 5 and to the right 2. So starting at a point on that line, so this y-intercept, we're going to go down 5 and to the right 2. We can also write negative 5 halves as positive 5 over negative 2. That means we're going to go up 5 and to the left 2. Again, starting at a point on our line, starting at this y-intercept, we're going to go up 5 and to the left 2. So we have 3 points that are on our boundary line. This inequality is a less than, so the points on the boundary line will not be included. So we're going to draw the boundary line with a dashed line. So we have our boundary line. Now we need to determine which side of the boundary line to shade in order to graph this first inequality. So let's pick a point on each side. I'll start with this origin, 0, 0. Again, you can pick any point you want. Just the origin with an x value of 0 and a y value of 0 often makes the arithmetic simple. So I'm going to go back to the original inequality. So this is 5 times 0 plus 2 times 0 less than negative 4. So this is 0 plus 0 less than negative 4. 0 less than negative 4. Well, that's not a true statement. So now let's pick a point on the other side. I'll go with a point on this x-axis. We'll pick negative 3, 0. So with negative 3, 0, this will give us 5 times negative 3 plus 2 times 0 less than negative 4. This is negative 15 plus 0 less than negative 4. Negative 15 less than negative 4. This is a true statement. Negative 15 is less than negative 4. This means we're going to shade down and to the left of this boundary line. So this is the graph of our first inequality. Now let's graph our second inequality. So we have x plus 2y less than or equal to 6. Let's start with graphing this boundary line. With our boundary line, we're going to replace that inequality sign with an equal sign. So we have x plus 2y equal to 6. And I'll go ahead and graph this boundary line by finding both the x and y-intercept. So if we set x equal to 0, we'll find that y-intercept will have 0 plus 2y equal to 6. This is 2y equal to 6. And then dividing both sides by 2, we get y equal to 3. So we have the ordered pair 0, 3. And so our y-intercept is 3. Setting y equal to 0 to find our x-intercept, we get x plus 2 times 0 equal to 6. This is x plus 0 equal to 6. So x is equal to 6. So we have the ordered pair 6, 0. And we're crossing the x-axis at 6. We have 2 points that are on this line. Our inequality is less than or equal to. So when we draw this line, we will draw it as a solid line to indicate that the points on the line are included in this solution set. Now we need to determine which side of this line to shade. Once again, I'll start with this origin, 0, 0. So we have the origin, 0, 0. We're going to plug these values, these x and y coordinates, back into the original inequality. So we have x value of 0 plus 2 times y, so 2 times 0 is less than or equal to 6. 0 plus 0 less than or equal to 6. 0 less than or equal to 6. And that's a true statement. So it looks like we're going to shade down and to the left of this line. But just as a check, I am going to check a point on the other side of this boundary line. And I'll go ahead and check a point on this y-axis. I'll go ahead and check the point 0, 5. And when I check this point, I should not get a true statement. I should not be shading this side of the line. So we have 0 plus 2 times 5 less than or equal to 6. This is 10 less than or equal to 6. And as expected, this is not a true statement. So we're going to shade the side of the boundary line that includes the origin. And so the solution for this system will be where these two inequalities overlap. And they overlap in this region here. So we can shade this region. And all the points in this shaded region are solutions to this system of linear inequalities. So if we plug those xy coordinates into both of those inequalities, both of those are going to give us a true statement. The point where these two lines intersect, this point is not a solution because it is not included in the solution set for the first inequality. And then looking at the two boundary lines, so starting with the boundary line for the first inequality, none of these points on the boundary line are included in the solution set. Looking at the boundary line for the second inequality, if we start at that point of intersection and we move to the left, these points will be included in the solution. But then from this intersection point and then moving to the right in the positive direction, these points are not included. And once again, the point of intersection itself is also not included in the solution because it's on that first boundary line. And then any point in the shaded section is a solution. What that means is if we randomly pick a point, any point that's in this section, so for example, we can pick -9, -3, we will get a true statement when we plug these xy coordinates into both inequalities. So for the first inequality, we have 5 times -9 plus 2 times -3 less than -4. -45 minus 6 is less than -4. negative 51 less than negative 4. That's true. And then with that second inequality, we have negative 9 plus 2 times negative 3 less than or equal to 6. Negative 9 minus 6 less than or equal to 6. Negative 15 less than or equal to 6. Also a true statement. A great way to learn is to practice on your own. We will discuss in a bit, but go ahead and pause your screen and do this problem. So to solve this problem, we're going to graph each of these inequalities, starting with this first inequality. So we're going to graph this boundary line. I went ahead and converted this into slope-intercept form, giving us a y-intercept of negative 1 and a slope of negative 3/2. Our boundary line is solid because this inequality is greater than or equal to, so the boundary line is included in the solution. Now we need to determine which side of the boundary line to shade, so we're going to test a point on either side. We'll start with that origin. When we test the origin, we end up with 0 greater than or equal to negative 2, and that is a true statement. But let's go ahead and verify, and we're going to test a point on the opposite side. Let's test the point negative 4, 0 on the x-axis. We end up with negative 12 greater than or equal to negative 2. This is not a true statement. So we will shade the side of the boundary line containing the origin. So we're shading up and to the right. And this is the graph of that first inequality. So let's look at the second inequality. Again, we're going to start by graphing this boundary line. And with this boundary line, I'll graph by finding both the x and y intercepts. To find the y-intercept, we set x equal to 0, giving us a y value of negative 4. Setting y equal to 0, we get an x value of 2, so the x-intercept is 2. Connecting these 2 points, we get our boundary line. In this case, the boundary line is dashed because we only have less than. So the boundary line itself is not included in the solution for this inequality. Now we need to determine which side of this boundary line to shade. Again, we'll start off by testing that origin, 0, 0. We end up with 0 less than 4. That is a true statement. But as before, we'll test a point on the other side as well. Go ahead and test the point 4, 0 on this x-axis. We end up with 8 less than 4. That is not a true statement. So we will shade the region containing the origin. Again, we're going to shade up and to the left for this boundary line. So this center region here is our region of overlap, and we can shade this region. So all of the ordered pairs in this purple region are solutions to this system of linear inequalities. Looking at the boundary line, so the boundary line for the inequality 2x minus y less than 4, all of the points on that line are not included in the solution for the system. Looking at the point where the 2 lines intersect, again, it's on that boundary line, so it is also not included in the solution. If we look at the first boundary line, so starting at that point of intersection and moving to the left, all of these points on this boundary line are included in the solution. Once we get to the point of intersection, moving to the right, these points are not included in the solution. Drop any questions you have in the comments. Continue practicing graphing systems of linear inequalities, and I'll see you in the next video.